Hello guys, today I'll be doing this Codeforces round 799. It is a Div.4 round and let's see how it goes. Marathon. Given four distinct integers A, B, C and D, three other people are running a marathon. The value A is the distance that timer has run. B, C, D correspond to the distances here. Output the number of participants in front of them. Wait, what? Two, zero, one. Number of numbers that are bigger than the current number. Yeah, this is correct. But what? Two zeros. Where's the bishop? All distinct. So show has an array A consisting of n integers. In an operation consists of choosing two positive indices I and j and removing ai and aj from the array. What was Q? For example, from the array, she can choose to remove first and 3. After this operation, the array becomes 3, 2, and 5. Okay, reduced by 2. Yeah. After he made some, yes, he has an array that has only distinct elements. In addition, he made operations such that the resulting array is the longest possible. More formally, the array after show has made his operations respects these criteria. The length of A is maximum. So extra occurrences of each number. So like here, 4 values need to be removed, right? I think this one is also somewhat easy. And run it again. No need of this. Also have a map. If m of b of I is more than 1, then do count plus plus, I guess. Right. So now, and then what do we need to output? The length of the final array. Okay. So if C and T is odd, then do C and T plus plus, and at the end just do C and minus C. Right. 2, 1, 2. Where's the bishop? 8 cross 8 chessboard, numbers and columns. Place exactly one bishop on the chessboard. Not placed on the edges of the board. The bishop attacks in all directions diagonally. No limit to the distance which the bishop can attack. Note that the cell on which the bishop is placed is also considered attack. Okay, forgot where the bishop was. So like the intersection of two diagonals. So current and that. That's not right. I is less than 7. J equals 1. J is also less than 7. And for int k equals 0, k less than 4k. V of I j equal hash I plus dx of k j plus dy of k if v of nx ny is equal to hash, then just add it to it. Like if c and t is equals to 5, then x equals to I plus 1 and y equals to j. See how that's. This is what we need. X equals 0, I guess. And yeah, there's some dx and there's some dy. So like it will be 1 1 minus 1 and minus 1. Similarly here 1 minus 1 1 minus 4 3 2 2 4 5. The clock and binary digit. 24-hour clock that shows the time in the format hour to minute. It looks at the clock every X minutes and the clock is currently showing the time as. How many different palindromes will Victor see in total after looking at the clock every X minutes? Different palindromes. The first time you get time as. So maybe I can just do we need to find a cycle or will we Just look at the clock. Like if the date changes, then that case is not considered. No, maybe that is also considered. And the times will continue to repeat. So what? Then what if the time is repeated? Oh, it, they want different values. Oh, makes sense. So yeah, I just need to find out that instance where a cycle is linear. Let's say S1 is S. Now int x, C. So while S is not equals to S1, right? So S of 0 minus 0 into 10 plus S of 1 minus 0, this is the R's, right? Now H plus equals to X by 60, then int M, S of 3 minus 0 into 10 plus S of 4 minus 0, right? M plus equals to X modulo 60, right? And then H plus equals to M modulo 60, M modulo equals to 60, and H modulo equals to 24, right? Now set S equals to string value of H plus this plus string value of M, and answer plus equals to check S. So this is also easy, S of 0 is equals to S of 4, and S of 1 equals to S of, no, S of something is missing. Okay, then let's just debug it. Oh, so convert it to a do. Infinitely minus 28. At what? No, not this. M by 60. No, still 10 minus 20. Ah, so okay, I see the problem. But then, okay, maybe this will not work. S of 0 will now become h by 10 plus 0. S of 1 will become h modulo 10 plus 0. Similarly, S of 3 will become m by 10 plus 0. And S of 4 will become m modulo 10 plus 0. This should work now. 116 10 0 1. Binary DQ has an array A of length n consisting of zeros and ones, either the first or the last element of the array. Minimum number of operations has to perform such that the total sum of the array is equal to S after performing all the operations. It works. Either the first one or the last. Oh, okay. So number of operations can be so minimum number of operations, which means that we need to find out the length of the longest substring of S, which sums up to S, right? Yeah. Or like in this case, an array is given to us, so longest sub-array. So maybe we can do a binary search for that. I think that will also work fine. So, and okay, now low should be if check D and mid is true, then Z is equals to mid and low equals to mid plus 1, as equals to mid minus 1. At the end, print out n minus z, right? And also minus 1. So if z is minus 1, then just see out minus 1. initialize it mid and the sum which is s. I is less than mid, right? So if sum is equals to s, then return true. Otherwise, for int I equals to mid, I less than d dot size I plus plus sum minus equals to d of I minus mid and sum plus equals to d of mid. If sum is s, return true, return. Okay, why is the fourth one is minus 1? This is the fourth one, right? And also for the third one, my answer is incorrect. As z is minus 1, then C out minus 1. Oh, so yeah, if so binary search will not work. Then maybe just linear. Okay, and let's say previous sum equals to d of 0. So okay, first handle the case if s is 0. It can be 0 also, right? No? Okay. Here, not if, but sum plus equals to d of I. Now while sum is more than s, do subtract d at previous position from s and do previous plus, right? And here answer will be equals to max, or not answer, but z will be equals to maximum of answer comma I minus previous plus 1, something like that. But yeah, in the case of minus 1, it will fail. So if s is equals to sum, then only do this, right? Wrong answer. Why though? Really don't see. Oh, so yeah, the value of n is 1, then I think that was really. So 1, 1 and 1. Like the answer should be 0, but earlier it wasn't 0. Right? Yeah, that's three sum A of positive integers length and three distinct indices ai plus aj plus ak ends in the digit 3. So only yes and no needs to be printed out. Hmm. So like there are not too many cases for getting or like to achieve this kind of condition. So maybe I can brute forcefully try out all of them and v of I. Now yeah, v of I modulo equals to 10, then do m of v of I plus plus, right? So maybe three for loops would be sufficient, or maybe not. That will run for like 1,000 times. So that might give a TLE. What else? Like the cases can be 0, 1, 2, and 1, 1, 1, and like 9, 4, 0, 8, 5, 0, but can also be 8, 3, and 2. Okay, so basically one number is confirmed, then we can split the other number into two parts. J equals to hmm, what? So like 9, 9 and 5 is also valid, no? So I can split it to 14 as well. but only in the case of first number being 9. But like in the other cases, when we are including an 8, then 8 plus 9 is 17 plus 6, so it can be 15 as well. So 23 minus 0 or 23 minus I. So J should be minimum of 18 comma 23 minus I. But no, that is wrong as well. Oh, so if I is less than 6, then we can go up till 18. And J is less than someone, hmm, why not just 3 for B and see if that works. Then X is true. So I think I missed something there, but I don't think this. And so Like this is not done. Here also I will have to do this, this, and then so if m of I greater than equal 0, then only this work. Otherwise, TL is no, a of length n, integer k, find the number of indices such that the subarray with length k plus 1 has the following property. If you multiply the first element by 2 to the power 0, the second element by this, then the subarray is sorted in strictly increasing order. Count the number of indices such that so the first number will not get multiplied with anything. Second one with 2, third one with 4, and so on. So the second number has to be greater than or equals to the first number by 2, or first number plus 1 by 2. It should be greater than that. But this, I cannot check this for bigger values of. Maybe I can, because like we are just multiplying it by 2 every time. So I think I can check that. Like in this case, after 9, so this number should be 9 plus 1 is 10, by 2 is 5, into 4 is 20. Yeah, that is right. But still, Or maybe, yeah, so if like the first four numbers are not in the correct order, then I should leave out that four numbers and check for the numbers, like start from the fifth number, the new series. Okay. Alright. So started with one if, and yes, count is also I minus 1 plus 1 by 2 is, but like in the case of 8 and 4, this will not work, right? But now this will work. Yeah. If CNT is greater than or equals to K, do answer plus plus. And if it is not the case, then do CNT equals to. In the last case, it should have been 0. With what? Oh, okay. 2, 3, 2, 3, 3. Okay. For each round, the player selects a number between 1 to 10 to the power 9. After that, a dice with these many faces is rolled so that a random number between that appears. If the player guesses the number correctly, their total money is double. Else it is half. Marian predicted the future and knows all the numbers that the dice will show in the next 10 rounds. He will pick three integers A, L, and R. He will play R minus L plus 1 rounds. In each of these rounds, he will guess the same number A. At the start, he has $1. asks you to determine the integers a, l, and r such that makes the most money at the end. Note that during halving and multiplying there is no rounding and there are no precision errors. So for example, during a game, Marian could have money equals to these, etc. Okay, so like for this, I can just have a count variable which will count the powers of 2. So negative powers will denote the division. Positive ones will denote the exponentiation. If there are multiple answers. There could be multiple approaches for this problem. One of them could be like if I fix a value of AI and then check for L and R. Like in this case, I am saying that I will pick 4 and then like for L and R also we'll have to spend linear time, I guess. So that's not optimal. And the binary search thing is also, I don't think if that great. And using 2 pointers, aren't there some extra constraints? So all that I need to do is to find a subarray in which a number is occurring multiple times, and that occurrence is the thing that will tell us the answer. So in this way, I think it- so yeah, the answer can never be lesser than 1/2, right? Yeah, it cannot be less than 1/2. Or maybe it can never be less than 1. Yeah. Will never be less than 1. Yeah, it will never be less than 1. So how do we do it? If I do binary search online, will that work or not? I mean, I don't think that we don't know. Or is it like some variation of Cardano's algorithm where the base condition is wrong? So right now, what what test case I am stuck at is like 4, 3, 3, then 4, and maybe another 4. So like if only this much is given, then the answer would be this. And then if there's 2 more 3s, then I should not include these 2 3s and 4s. But if like there wasn't this 4, then it was good to have these 2 3s. What are the standards? for binary search, like on the answer, like the power of 2, then the minimum value of that could be 1, and the maximum value will be the maximum occurrence of any number. Okay. So all that I need to do is to like find out some segment or some subarray of the given array. Like if I am doing it in the brute force way, then I will try out for each possible values from low to high and say that it is a candidate answer. So like, is it the case if there is an answer with power 3 not possible, then an answer with power 4 will also not be possible? Maybe it is. So like if some cases like this, for gaining 2 powers I will have to spend 1 power. So in this case, power of 2 is possible. Power of 3 is also possible actually. Oh, like how to check for that is another question. Which is actually the interesting. So I think that that thing can be achieved. That is not a hard thing to see, right? Yeah, think I got it. Think so. Let's see. And yeah, finding out that L and R values is also not all that tough thing. Mm, let's have pair of int check vector of int v and mm, let's say size, and actually that is not required, but oh, think I should first coordinate compress the values. Yeah, int n, or I think that is also not required, just cnt or like the mid value. Now here for vector of int or int I equals for int j equals to mid j less than v of I dot size j plus plus mid minus answer or if v of I j minus v of oh I thought I can check that thing linearly. Like in this case, in the vector of 8, I will be storing 1, 2, and 3. And if I want to check, like the candidate answer is 3, then I will just find out the difference between these indices and check. That will not work for many reasons. But here I think some other thing will come into picture, which is okay. And current equals 0. Let's just say it is 1. If let's say it's extra, so extra plus equals to v of I j minus v of I j minus 1. Let's start it from 1, right? And minus 1. Okay. And do current plus plus. If at any moment extra becomes greater than CNT, then set CNT equals to 1 and extra equals to 0, right? And if at any moment current minus extra becomes greater or equals to mid, then then just return true, else return. I think we have written the code for coordinate compression somewhere. No? Okay, so I will have to write it now. CORs. Hmm. V of 5, right? V of VBI, the second is now this, right? No, is equals to I. Wait, what? No, wait. So in coordinate compression, what we do is just that we replace the numbers with their relative position in the sorted array. So yeah, this is correct. And then yeah, the array that I need to return is the mapping one, right? So something like this. Not pair, but a vector. V of I is 0. I previous and VVI and G. And here previous equals to VVI. Not VV. Oh, okay. Hmm. It should not be like this. Okay. Let's have another vector. And then now mm, V dot size only. Now what? And I think there should be a reverse map as well. Like I know that at zeroth position 6 belongs, but how will I know that 6 belongs to the zeroth position? Okay, so I think I will have to create that reverse map myself. Reverse map of V of I, not V of I, MP of V of I is equals to V of I, right? And then hmm, frequency of, so V1 I, because something like that I will be doing. And here I think the reverse map thing will come into place. Yeah, I think so. Right. And low equals to 1 and high equals to mx. And it's not required, right? You can just remove it. So if it is not empty, then I will do something else. I will do some other thing, and that other thing will be to say that this answer is not possible. Otherwise, so let's say it is a vector of n which is initially empty is equals to result and low equals to not place. Okay, now see out. Yes, some answer will definitely exist. MP of answer 0 space answer 1 right. So and yeah, one more thing that I can do is answer 0 is equal to 1 or yeah, don't no need to do that. But here the only thing that I'm worried about is that if mid is 1, then just return, I mean just I and not 0 and v of 0 0 v of 0 0. And nope. Okay. Oh, okay. Wrong answer. Wrong answer is pin. 580 right solution. This is all right. Then this. a problem. Like the maximum answer could be equals to the maximum frequency only, right? Yeah. So maybe similar is Fij minus j minus 1 minus I to current plus so if at any moment xy exceeds the value of current, then I am setting current equals uh, like is this thing in current V of I g. How could this be wrong? The same number A, he has a dollar. I don't think the answer can never be equal to these values. Am I missing something? So what happens in this case? Maybe this was, but that should not cause any error. Wait, what? This was really don't know how that was a perfect answer. Do they ask for the smallest line? I don't know. Just barely saved the day for me.